Academy podcast with Michael Roper here, and this is episode number 494. So, welcome to our podcast. Today's podcast is going to be about how trained operators can reduce energy costs and also downtime. Now, we're going to be covering a lot of nice topics within this title here. We'll be talking about why it's important to have a trained building operator in the first place, what advantages that can have, and then we'll get into the role of a building operator, and more specifically, a trained operator and what they can do. We'll also get into real-world energy savings examples on what a trained operator can perform, and then also some downtime reduction through skilled intervention or preventative maintenance. And then last segment, we're going to talk about how companies can train and also empower operators to help run their buildings. All right. So those are going to be the topics that we're going to talk about today. Now, all this information that I'm covering today can be found on our website, and that's going to be podcast.smartbuildingsacademy.com/494, because this is episode number 494. Okay, so let's go ahead and get started, and we're going to talk about why it matters to have a building operator that's properly trained, that's got a wealth of knowledge and experience in building automation, and maybe not even just building automation, but mechanical systems in general. So first of all, the reason why it's important for energy efficiency is commercial buildings account for 40% of the global energy use. Okay, so that's not counting the residential parts of it or anything else. That's just commercial only. So that's 40% of the global energy use. That's a lot of consumption of that gas and electricity. So that's a major reason right there for energy savings. Another one, even the best system can't compensate for poorly trained staff. Okay, so you can have the most expensive, the most elaborate building automation system, the highest efficiency equipment, but if you have a poorly trained staff, there's a good chance that some of that system may not be working to its full potential. You could be saving more money in energy efficiency. You could be getting less complaint calls from your tenants as well. So a poorly trained staff doesn't override an expensive or a high quality brand name or a system that you put into your building. Now, the last part is really important. And so when we think about a building automation system, we think about controllers, field controllers, supervisors, user interface software, field controller software, end devices. But one of the most important pieces, in my opinion, to a building automation system is after we install the system, and it's the human layer that maintains that system after it's first installed. So the operators are going to be that human layer that we're going to leave the system with as BAS companies. After we do our startup and checkout, they're going to be responsible for maintaining that system and keeping it up and making sure it performs the way it was designed to be used. Okay, so that's the human layer of the building automation system. That's what the building operators are. They're the building layer. They're a critical piece of the building automation system. And we'll talk more about that and give some examples where that's going to make a little more sense. Okay, so let's go ahead and start on our first segment that I wanted to talk about here. And that's going to include, what does a trained operator actually do? What does that look like when a trained operator can perform duties that they're supposed to do to make their building run efficiently, energy-wise, and then also prevent downtime? So the first thing a trained operator can actually do is they need to understand sequences, okay? Sequence of operations, how things work, how equipment works, how the hydronic system is supposed to work, how the air side system is going to work in the HVAC. Maybe they have a lighting control system too as well that's tied into their BAS. They're going to have to know about the lighting system too. Okay, if there's any access control or security, fire alarm, they're going to have to understand the sequence of operation of all these different systems in order to understand how to troubleshoot them, understand how to do some predictive maintenance. They can predict if something's going to go down and things like that. Okay, so someone that's going to be very wise, I guess you could say, on the sequence of operations, on these mechanical systems. Okay. Also, a trained operator is responsible for maintaining goals in a building. So these are often called KPIs, or key performance indicators. All right. And all these is basically business objectives that the company wants to make. These might be goals, like they want to reduce energy by 20%. That might be a goal they have. They might want to reduce complaints by 10% from the previous year. Those are some examples of key performance indicators that could pertain to a building operator in the maintenance department. They might also track run hours. Okay, they might not want to run their equipment for a certain amount of time. They might just have some limits on it. They might have some temperature KPIs too as well. Another thing a trained operator should know how to do is to interpret alarms and alerts and not just acknowledge them. Okay, so I don't know if we have any BAS technicians or engineers watching right now, but I'm sure you've been up to a customer job site. You go to their user interface and you see their alarm log is just clogged up with alarms all over it, with critical alarms, unacknowledged. So you know they haven't been maybe paying attention to them. They might have been too busy to get to them, or they might have fixed it and just forgot to acknowledge the alarm that's in the alarm log in the user interface software. But they're also going to have to know more than just acknowledging them. They need to interpret what's going on there. So if they get an alarm, maybe they have a compressor failure alarm. Well, that could be due to something maybe upstream from the system. So they need to know how to interpret that alert and that alarm and not just acknowledge them and go on their day. So that alarm will quit bothering them. Another one we have is adjusting control strategies. Maybe it's seasonally. Okay. Maybe, in the fall or in the spring, they might be focusing more on some economizing strategies. They might be doing some different set points. Okay. They might be doing some outside air reset, things like that. So they're understanding about specialized sequences of operation and adjusting those control strategies seasonally, or even if an occupancy changes. Okay. They need to be able to know how to adjust a schedule, for example. Okay. Maybe, there's a exception to the calendar. There's a special event that needs to be taking place. So they need to take a look at that and be able to modify that schedule so they can accommodate their tenant needs. Okay. Because if you don't turn on something after hours that needs to be on, obviously that's going to be considered downtime and you might get a complaint from the tenant. Okay, so that was a few examples of what a trained building operator can do, what they might look like. So let's go ahead and go on to the next segment, which is going to be segment number 2. And in this segment, I want to talk about how trained operators can cut energy cost. All right. And we're going to start off with the software. We're going to start off talking about overrides, being able to spot overrides. So a lot of times, as you'll see, if you've been out in the field a little bit, we use overrides a lot. We use them to test equipment. We try to trigger failures to see if something will fail to make an alarm. We override outputs to make sure they turn on and off. We override analog outputs to make sure they rotate and open and close the way they should. Now, the problem is if we don't release those overrides before we leave, okay? So you don't want to leave like your supply fan running and override it on all the time where it just stays on all the time. Or your compressor, maybe you enabled a cool stage and you just left it on 100% or just on all the time, okay? Make sure a trained operator would know that, obviously, that they need to release those. It's a habit. They've had experience in doing this, and they understand what the consequence would be if you did not release that override, okay? It's going to increase energy, okay? More things are going to run if you leave things on, okay? Or if you turn things off. Maybe you turned an air handler off or a rooftop unit off, and now you turned it back on, and it's in the middle of the day in the summertime, and it's going to take a long time to cool your building down again. Okay, you're going to use more electricity by doing that. Okay, so that's overrides. Another thing that I've seen a lot that an experienced operator that's good at is scheduling. Okay. They'll get rid of unnecessary schedules. If you'll go up to their schedule and their user interface, it's all nice and neat. Everything's up to date. There's not any unnecessary schedules there. Okay. Tenants change their times they do things year to year, sometimes month to month or week to week. All right. So you got to keep up with their schedules and make sure if you're managing those schedules, the building operator should know that. This could also save energy. Imagine if maybe one of your tenants started going home at noon on Fridays and you didn't know that, but you left the building occupied until 5. So that's 5 more hours of occupancy that you left that building running because you weren't up to date on the tenant and when they needed that equipment to run. Okay. And any unnecessary schedules. Okay. Maybe we're running things when, they shouldn't be, or not running it when they should be. Then you'll get some customer complaints. Okay. So that's a little bit on the software. Something else on the software I want to talk about too is the trend logs. A good operator that's trained will know how to use a trend log to help save energy. Okay. Now trending, it's connected a lot with energy dashboards. An energy dashboard just has, power consumption, whether it be the whole building or you maybe sub-meter certain equipment or whatever. But that's what the energy dashboard would be, like a central place where you could see the consumption of all the equipment in your building system. Now, a trend log can help troubleshoot issues before they become bigger issues and waste energy. Okay. You might run a trend. You might see your energy consumption go up on your chiller after hours and you want to know why. So you might run a trend on the compressor on the chiller, see how long it's running, and maybe run a trend on a few spaces to see what those temperatures are doing after hours. What's causing those conditions? You might want to also monitor the outside air damper to see how often that's opening, how much it's opening, and maybe ask yourself, can we decrease that percentage a little bit and close it off and not let so much outside air come in that can mess with the environment? Okay, so trending, energy dashboards, if they can read those effectively and communicate those, that is another great skill that a trained building operator would know. Okay. Also fine-tuning set points. Okay, making sure your set points are where they should be. I mean, a lot of times it's based on the design from the design engineer, the mechanical engineer. However, maybe there's some conditions that changed. Maybe there was a remodel in the building. Okay, maybe they just reorganized, some different furniture, or maybe a coffee pot is by the temperature sensor or something like that. I don't know. There could be a lot of factors that affect that, but fine-tuning that set point could really save a lot of money on that. Okay. Also, PID loop tuning can involve that too. If a building operator knows how to use BAS service software and they know a little bit about PID loops, they would know about, your constants, your P and your I and your D, just the basic rules of thumb on how to tune up a PID loop would be very valuable for a building operator. So that was like the software pieces of that. One of them that's a physical piece is troubleshooting and doing preventative maintenance checks on the building automation system. Okay, so this would be, one of them is just identifying failed sensors or sensors that are out of calibration. All right, and this is very common, especially after year 2 or so, when the sensors might start to drift a little bit from the accuracy, from the tolerance that was from the spec. So what you're going to have to do on that part is you'll see the trained operators or the building engineers, they'll have a maintenance routine and a schedule, a checklist, and they'll have a certain time frame when they go out to check all these sensors, like a temperature sensor, humidity sensor, CO2 sensor, things like that. They'll have a calibrated reference with them, some kind of probe that measures temperature or humidity, and make sure it's recently tested. And they'll test it against the what's in the building, and we'll see if it's failed or not, see if it's within calibration. If it's not too far out of the range, you can put an offset on it. Okay, building operator could do that, or they can just replace the sensor at that time. Make the decision to invest a little money, replace the sensor, and then they don't have to worry about it failing when you don't want it to fail. Okay, usually that's after hours or something like that. And that's something we do not want. Okay, I remember I was working with a customer on a hospital one time, and he was noticing huge spikes in his chill water usage because we had the BACnet interface to it and we could see the chiller consumption. And he was actually running trends on it, just curious to see how much electricity it was using. And he was noticing it would spike. It was just started spiking all of a sudden. And on that, on the trends, he started trending some information. So he trended all the sensors on his air handler. And what he found is a humidity sensor. He kept it was like 10% higher than actual. So we went to the sensor and we had a calibrated reference, a humidity sensor on it. That's from the factory or somewhere that was calibrated precisely. And we noticed that it was a 10% higher than actual. So we were reading 10% higher. The set point for the humidity on the return air was 50%, but it was actually reading 60%. So it was really just the chill water valve was open the whole time, all the time in the afternoons in the summertime, when it was humid outside, because we'd bring in minimum outside air. And where I'm at in my location, it's very humid here in Oklahoma in the summertime, by the way. So just a little bit of humidity will cause a great negative effect on the building there. The dehumidifier and the chiller, the dehumidifier sequence and the chiller were fighting each other. So we replaced that sensor and it corrected the control loop, and we trended that information, and that chill water kilowatt usage did go down after that. Okay. Because we were not using that dehumidifier cooling coil valve all the time in the afternoon. Okay. So some key takeaways on that, doing things like making sure we don't have simultaneous modes going on at the same time. Some of the software conditions, being just aware of how a sequence of operation works. Make sure you don't have heating and cooling going on at the same time. Make sure your outside air economizer temperature set point is right. It's not like 80 degrees, you're bringing in 80-degree air. So just little things like that, if the building operator can be aware of that, that's very powerful. Also shutting off lighting or HVAC in unused areas. We talked about scheduling. That's a huge thing. That could be a big energy waste right there if you do that. And then also managing demand charges by pre-cooling buildings. We didn't really talk about this that much. This is another software feature. It's called Optimal Start. All right. And demand charges are a little bit different, peak demand, but if you want to pre-cool your building before your tenants get in the building, you have something called Optimal Start. So what that's going to do is it's going to check the outside air before you're occupied. So it happens during unoccupied mode, and it's going to predict when to turn on the equipment to best cool or heat the building before your customers get in the building. All right. So it's basically a software algorithm that's built inside many modern BAS softwares that I've seen, software applications, and it'll basically predict when to turn on the equipment to make sure it's comfortable before the tenants go in the building. Also, a building operator that is aware of demand charges, peak demand. All right. Certain times of the day, specifically in the summertime, electricity is very expensive. That's called the peak demand hours. Okay. So we want to be able to have the ability for them to determine what units we can shut down during peak hours or what set points we can lower during that time for cooling. Okay. So that's just based on experience, knowing their building, and also knowing their software. Okay. So that was segment number 2. I'm going to end that one on segment 2. We're going to go to segment number 3. And in this one, we're going to talk about preventing and reducing downtime. So this is really important for the building operator just to be aware of what can prevent and reduce downtime. So number one is recognizing early warning signs. So this can be done usually on preventative maintenance checks. Could be a troubleshooting check too as well. For example, you might, for a BAS tech, we might be checking the voltages on the input to the power supply on the controller. If we notice that according to our data sheet, if it goes outside the current or the voltage range, okay, maybe that's 24 volts and we're reading 27 or 28, on current, on voltage, that means that we might have an issue with the controller or the transformer. Okay, so we might need to determine to replace that transformer or replace the controller. That controller's getting anywhere near, the 10 to 15 year range. That's usually when ASHRAE says to replace DDC controllers around year 10. Sometimes it could be earlier, sometimes it could be later. I know a lot of us have probably seen controllers that are 30 years old. Okay, so that's an example of early warning signs. Okay, that's usually done on preventative maintenance checks, troubleshooting, and things like that. Also, handling alarms intelligently, like I talked about before. I think I've already covered this. A lot of times you'll see building operators just clearing them out. They'll see a critical alarm in the alarm log on the user interface software, and you have to acknowledge it. You have to click it and say, acknowledge. A lot of times they might not check it. So we need to make sure that we go check the issue, communicate the issue back to the team, and go from there. So handling alarms intelligently, making sure you set up alarms that are useful. Don't just set up an alarm for anything. If it's a critical alarm, make sure it's set up as a critical alarm. If we have a chiller that goes down, that's a critical alarm. Don't make it a notification alarm. Okay, we have a high or a low temperature cutout. That's going to be a critical alarm. Another thing that they could do to reduce downtime is routine checks. Okay, this is very obvious. I know everybody probably knows this that's listening to this, but it's very important to do PM checks, preventative maintenance checks, whether that be weekly on some things. Okay, some things might require a weekly check. You might have to do like a weekly routine, like a backup on your user interface. You might want to do a weekly backup on all your field controllers and set that up. There's a lot of software now where you can do it automatically. You can set it on a schedule and it'll automatically back that stuff up. Okay. Also, calibration on VAV boxes. Being able to understand how to perform a calibration sequence through the software. Tuning up the air valve damper and also the chill water or the hot water valve if there's a hot water valve on it. That's important too. Commissioning and recommissioning. So a lot of times a building is only commissioned one time and that's at the very beginning and it never does it again. An experienced and a very good, well-trained building operator will know that recommissioning needs to happen at least every 2 to 3 years, if not every year, if you can afford to do so. And there's also software within the building automation system that can do auto commissioning. Okay, and some modern software. Not all of them can do that, but most of them can these days. Okay. Also, understanding any kind of software updates, any kind of backups that you're going to need. Understanding how firmware works. And making sure that's up to date. If it's not up to date, we don't want to have a crash on the system due to someone didn't do a software update. Something simple as that. Okay. So that's the software piece. Another thing that's important too is being a very good troubleshooter. All right. And this is understanding upstream and downstream impacts of the BAS, of the building automation system. Okay. For example, if you have an air handler, okay, we'll say it's a VAV air handler. We have a discharge air temp at the end of it after the supply fan. Okay. So anything that's upstream from that discharge air temp, he needs to have a good understanding of what happens in the sequence that can cause that temperature to either rise or to fall. Okay, so if you think about it, he's going to think about the functionality of each device and each sequence that's built into the software before it gets to the discharge air temp. Okay. And what input does that discharge air temp control? Okay. All right. So you're looking at things like the outside air damper, the mixed air temp, the chill water, the chill water valve on the VAV air handler. Those are all things that can have a direct effect on the discharge air temp. And then from the discharge air temp, whatever happens to that, what can happen downstream to the VAV boxes? Okay, if we have 80-degree discharge air, that means we're going to have very hot air go into our building spaces. So they can use that to help them troubleshoot upstream and downstream of the system. Okay. All right. So that's segment number 3, reducing downtime. Then the last part, segment number 4, I'm going to talk about how to train and empower operators. All right. This is one of my favorite parts because as a trainer, obviously, I love education. I think this is really important for a lot of building operators. And when I was in the field and doing sales and as a technician and as an engineer, I noticed a lot of them would say that they want training, but they can never afford it. And that's really sad because, training, especially today, it's everywhere. It's just knowing where to get it and where to get the good quality stuff. Okay. And what pertains to your building. So it's important to have ongoing building automation training because there's a lot of different manufacturers out there, and you might even have 2 different manufacturers in their building. Okay, so they might have to manage 2 different systems. So that's going to require even more training. Okay, a lot of these systems are becoming very complex. We're actually introducing AI now into our field, where we're getting data, the Internet of Things. All of our devices are being connected to the internet, and it's going out to a cloud. It's usually going to go to some kind of AI type processing to where we could do predictive maintenance, energy efficiency, making these things called digital twins, do tests to see what would happen in certain situations. So things like that is going to increase not just BAS specific training, but also, other software training like artificial intelligence. That could be something that the new building operators are going to have to know in the future. Okay. So that's good. Get them in a class, give them a sandbox type atmosphere to where you can build something on the user interface where they can't mess anything up. They can just play around with stuff, override inputs and outputs, and then maybe have some kind of structure as you go through their training. Shadowing senior techs is very good too, depending on the senior tech. Now, I will say, the senior tech that I was with when I first started he was a nice guy, but not a very good communicator. But yeah, something you need to be aware of. Senior techs are good as long as they're willing to teach your technician. Okay. Things that are good to learn during this time is commissioning. Okay. Take them through a senior tech and have them watch what they do during commissioning. Go through all the point-to-point checkouts, go through the sequence, the functional testing and all that stuff. Have your senior technicians show them what you guys do during seasonal transitions. If you have a 2-pipe system, what you do there, what you do if you, with your outside air dampers and you're economizing in the spring and the fall and things like that. And I talked about already, just give them access to the tools, the software tools and things like that on your user interface and your service tool software as well. And just to encourage curiosity. A lot of times ask why, not just what the answer is. Okay. Why did your damper actuator not open all the way? Okay. Why is our pressure building up, in our chill water system? Don't just ask what it is. Why is it? Have them explain it to you. These open-ended questions really engage curiosity and expands learning too as well. Okay. All right. Well, that's pretty much all I want to talk about on my segments. Some key takeaways we talked about today that's really important is trained operators are not a luxury. They're not just something that would be nice to have around. They're a necessity for a successful building to run the way it should. All right. And you can definitely see the difference between a building that's run by a trained, experienced building operator and one that is not, because I've seen both of those types, and maybe you've seen those too. I don't know. And savings are not just theoretical. You know, if you have a trained building operator that can do these things, that knows how to do this, millions of dollars are saved yearly across all different types of sectors, all different types of commercial buildings when you have these trained operators. And then downtime prevention is just as critical as energy savings. Actually, to be honest with you, it's more critical than energy savings, because if you think about it, downtime can affect health issues in buildings. It can affect damage to buildings. Too much humidity in the building can ruin documents. If it's too hot or too humid, somebody with a health condition, they can get sick really bad. You don't want that. If you're not getting enough, outside air intake, people can get sick, then get headaches, and then get nauseous. All right. So things like that, downtime's not good. Also, you don't want your good employees to leave your company because your building's not comfortable. Okay. So that's another thing too, as well. All right. Well, that pretty much wraps up our website, or our podcast for the day. Thank you for listening to the Smart Buildings Academy podcast. And I hope you learned a lot from this episode. And if you found this episode valuable, please leave us a 5-star review on Apple Podcast or Spotify if you're watching it from those two. If you're watching it from YouTube, please like, comment, and subscribe. And if you're watching from LinkedIn, please share this with your network. And as always, this will be available on our website at podcast.smartbuildingsacademy.com/494. All right. Thank you very much.